This tutorial will cover heat exchanger and horizontal vessel isolated foundation design using the Plant Mode and STAAD Foundation Advanced. On the opening screen, click Plant Mode and then Create Heat Exchanger or Horizontal Vessel Foundation. A wizard will pop up with a sequence of steps to create the foundation design. The user can skip to any step using the navigator on the left or go in order. The first step, Heat Exchanger Job, requires a Heat Exchanger ID or title. The ID is to allow and differentiate between multiple heat exchanger jobs in the same file. Then select the unit system and design code. In the Heat Exchanger Geometry tab, you must specify whether the job is single exchanger or stacked exchanger. If single exchanger is selected, then both upper exchanger diameter and spacing of exchanger inputs becomes unavailable. These two inputs are the only parameters in a heat exchanger wizard which are affected by the single or stacked exchanger selection. I will select stacked exchanger. Then finish editing the exchanger geometry values. Remember to have the correct unit selected. All of the exchanger geometry inputs except water table depth are shown in the exchanger layout diagram. This diagram is also updated for exchanger or vessel type and footing type selections. For this tutorial, I will cover the isolated footing. Heat exchanger with combined and strap footings are covered in a separate video. Bottom of footing elevation will be used for the detailed drawing only to show elevations of different levels. In footing geometry, select the appropriate unit type. All of the left and right footing values are adjusted if a new unit type is selected. If you want both footings to have the same dimensions, then select the identical footings option. Using this option, one set of inputs is required, which will be used to design a footing that can handle both load cases. If unchecked, the program will design each footing separately. In either case, at least one set of footing inputs should be specified. Minimum and maximum options allow the program to calculate the most efficient and also a realistic design. The length and depth increments are set, but customizable, to the PIP standard of 2 inches to allow the use of standard manufactured forms. Peer-to-peer distance may also be inputted. In primary load cases, 8 heat exchanger loads can be entered. The first, empty load, is, according to the PIP Design Guide section 4.2.1, the empty weight of the exchanger or vessel including all attachments, trays, internals, bundle, insulation, fireproofing, agitators, piping, ladders, platforms, etc. Any eccentric load should also be added to the empty load. The descriptions of all of the other load cases can be found in the PIP guidelines. 4 user-defined moments may also be entered. Pier load distribution allows the user to alter the distribution of loads between the piers. The slide plate coefficient of friction and self-weight factor can also be entered. In wind load generation, the user has the option between user-defined wind load and calculated wind load. If using program calculated wind load, multiple wind design parameters are required. Their descriptions are shown in the blue box. 2 values, KD and I, are taken from tables which can be viewed here. The program uses these inputs to calculate the shear, moment, FZ, and MZ. If these values are known, then select user-defined wind load and input them manually. Entering a partial wind load for test and erection loads is optional. STAAD Foundation Advanced requires the shear and moment in both X and Z directions for empty load case and operating load case for the heat exchanger foundation design. These values are inputted or calculated in the seismic load generation section. If they are known, select directly input seismic load to enter the values. If not, other parameters become available which will generate these values for you. The other parameters include response modification factor, R, and importance factor, I. Also, the user can choose to enter seismic ground motion values manually or select using zip code. Fundamental period values must also be entered if you're not directly inputting the seismic load values. In the load combination section, service and ultimate load combination tables are shown similar to the load combination tables in general mode under loads and factors. Here the user can choose to use either ASCE 705, PIP, or user-defined to enter his or her own load combination values. If ASCE 705 or a PIP design code is selected, the values in the table can still be edited. Design parameters provides input for the necessary parameters used for concrete and reinforcement and footing geometry design. They're separated into concrete and reinforcement and cover and soil parameters. Additionally, a coefficient of friction, factor of safety of sliding, and factor of safety of overturning can be edited under sliding and overturning. After all of the steps have been completed, click Finish. This example says Edit because I switched to an existing example file to show standard values. The heat exchanger can now be viewed in the geometry view. This is a graphical representation of the user's input with a typical horizontal vessel. From this point, you can either edit, which takes you back to the heat exchanger creation wizard to edit any section, or you can delete or design. You can also input any number of plant foundations in the same file. Designing creates a calculation sheet and detailed drawing. Calculation sheet specifies how each footing was designed. It includes detailed steps, figures, and references to the code which was used for design. Let's take a closer look at the punching shear check shown in the calculation sheet as an example. Here, steps to check the first pier is shown. The equations are shown along with their references to ACI code. As shown, the design passes this check. Detailed drawing gives plan, elevation, and footing pedestal plan views for the footings. This drawing shows support and footing dimensions and any reinforcement. Thank you for watching this tutorial.